We're back again. We're going to do another problem. This one is on integration. I'm given the derivative and I want to find the cost function. Given the derivative is 3.1 e to the 0.04t. Also given that c at 0, a fixed cost is $100. Take the integral, dc, respect to that. That is the exponential integration rule up there. I have to find a. U is always the power of the exponential. F of x, there is only one. There is no f of x in there, so you assume it's 1. And du dt is 0.04. So ct equals 3.1 e to the 0.04t. 1 over 0.04 plus c. This is not a definite integral because they don't give me integration range. So we have a c. So ct becomes 3.1 over 0.04, which becomes 77.5. Notice this was on quiz number 7. A lot of people got this wrong. E to the 0.04t plus c. Well, we're not finished yet. We want to find c. That's this c. All right, well, I'm given when c is 0, the value of c is 100. So make t equal 0, 77.5 e to the 0.04 times 0 plus c. So C0 is 100. We put that out here, it's given to me. This is 77.5 e to the 0.04, actually 0, equals 77.5 times 1. E to 0 is 1. So C equals 100 minus 77.5, or 22.5, is that what it is?
Yep.
22.5. Therefore, your answer, your full answer, is 77.5 e to the 0.04t plus 22.5. And that's what you need. They could ask you to find the cost at a particular time. You just put in time for t. If t was 10, you put in 10 here and 10 here. All right. That's one of the ones that people had trouble with on quiz 7-8. And now I'm going to go over another, I put it back in the right place this time. Implicit differentiation problem. Because as I said, people seem to have problems with it. So let's do this. I have 3x squared plus 2x to the third y squared minus y to the fifth equals 7. I want to find dy dx. So everything is with respect to x. So I look at all these functions and I take them with respect to x. This is a product rule. I could call this u and this v. Get a lot of product rules in these. So it's 2x third d dx of y squared plus y squared d dx of 2x to the third. minus d dx of y to the fifth equals d dx of a constant 7, which we know equals 0. All right, now here's an x and an x. I'm allowed to do that. I'm taking the derivative with respect to x of something with x in there. It's going to be 6x. Let's look at this one. It's 2x third. I'm taking a derivative of y with respect to x. There's no x here. I can take it with respect to y. So I set up a dummy, pick to y. Then I have to balance it with dy dx. Once I take a dy, the balance function must have a dy in the numerator. Here, d dx, x and x, I can take that. It's going to be 6x squared. And here I cannot take this with respect to x. So I have to once again set up a dummy. And then to balance it, have a dy in the numerator. And that's 0. So let's see what we get here. We get 6x plus 2x third. The derivative of y2 is 2y. And I have the attachment, which I have to keep. Plus 6x squared y squared. Minus the derivative of, that's y to the fifth. It's going to be 5y to the fourth with the attachment dy dx. All right. Let's erase the bottom part here. And continue. We'll clean things up a little bit. 4x third y dy dx plus 6x squared y squared minus 5y to the fourth dy dx. All right, now I'm going to bring all terms not in dy dx to the other side. Minus 6x minus 6x squared y. I'm going to put that over here. Minus 6x minus 6x squared y. Okay, we'll check that everything's coprosthetic there. Looks like I did everything right so far. These cancel. Now I have 4x third y dy dx minus 5 y fourth dy dx equals minus 6x minus 6x squared y. Well, since I want to solve for dy dx, I'm going to factor the dy dx. Well, I get dy dx 4x third y minus 5y to the fourth equals minus 6x minus 6x squared y. Now, since I want to isolate dy dx, I divide both sides by this. So I'm left with my answer, minus 6x minus 6x squared y, 4 x to the third y minus 5 y to the fourth. That's my answer. This is the most complex you would get. Basically, you have an answer in terms of x and y. So you need x and y. Most of the time they'll give you one of the values. They might give you x, and you got to find y by substituting back into the original function. So you need an x and y to find a value of dy dx. So they might say, find the value of dy dx when x equals 1. I would have to substitute back into here, x equals 1, and solve for y. Okay. How much time have we covered?
This is we're at about 11 minutes.
Oh. Okay, so I guess what we're going to do is we overshot this session. We're going to stop here, and we're going to do the review class tomorrow, and you will get all information on the time, and whether we're going to do it interactive or not depends on whether the webcam we have works or not. But you will get an email on this. This is Saturday that I'm taping this, so you'll get the email before you even see this class. Okay, see you next time.